to my YouTube channel. I hope you are fine. So, in this playlist, we are discussing about the statistics and probability concepts. In the last lecture, we covered about the measures of central tendency, where we discussed about the concepts like mean, median, mode, and we also implemented it in the Python using the stats module. So, today we will going to understand the second form of descriptive statistics, that is the frequency distribution. So, what is this frequency distribution? Frequency distribution, what it gives is, it gives how the data is been distributed in the particular form. Like, let's say, I will take one example to tell what is frequency distribution. Let's say, I will take one example. Let's say you are having 5 points. Let's say you are having data as 5 points. Let's say you are having here we are having 1, then we are having 2, then here we are having 2, then we are having 4, then here we are having 5. So now here you are seeing that this 2 is repeated twice. Okay. So this frequency distribution of data tells how much percentage of this 2 is there in our data. How much percentage of 2 is present in our data. So let's say here this 2 is present twice. So we'll take 2 upon what is the total 1, 2, 3, 4, 5. What that is the total. If you calculate 2 upon 5, you will get the value as, if we divide 2 here, we'll say 5 here. Here we will write 0, 20. So 40% of data is our 2. Okay, 40 percentage of our data is 2. So to understand how much data is present in our data set, what is the percentage of that value present in the data set, that will be decided by the frequency. So we will going to study about the three concepts, that is what is frequency, then we'll study about the relative frequency, then we'll study about the cumulative frequency. This is very easy, not that difficult. So what is frequency? Frequency tells how many times a specific value appears in your data set. So what is this? What does this mean? Let's say you take this particular example as, let's say, this data set. Okay. So in this data set, how many times one is present? So I will mark it with different color. This one is present here. This one is present here. This one is present here. How many times one is present? 3. So that's why here we created the frequency table and we put it as 3. So how many times 2 is present? We'll show you different color. This 2 is present here. Let's say 1, 2, 3, 4 times 2 is present. So that's where we written as 4 here. So total, what are the numbers that are present in our data set? We are having the numbers as 1, 2, 3, and 4 we are having. But these four categories, let's say these are the four categories, and how many times it is how many times is 1, 2, 3, 4 is present in the data set, that is decided by the frequency. Okay, how many times 1 is present, how many times 2 is present, how many times 3 is present, how many times 4 is present. So by doing this, what you are doing, you are trying to find out how much a particular number is present in our data set, how much percentage of number is present in the data set. So what is the significance of doing this? So let's say you are having a particular data of 5 rows, let's say, and in the 5 rows, let's say you are having in 2 rows, you are having in 3 rows, you are having two, in fourth row you are having one, in fifth row you are having one, let's say, and in we also had one more row in that we don't have the value. So what value we have to keep there? That value identification you can use using the frequency distribution, this thing frequency. So now here 2 is 4. Then how many times 3 is present? 3 is present here 1, 2 times. So 2 times 3 is present. How many times 4 is present? 1 time 4 is present. So 1 time. So what is the total sum of this data? Like total number of observations, if you say 3 plus 4, 7, 7 plus 2, 9, 9 plus 1, 10. So this is one of the very important topic that we have to discuss. So what does this? So what is the real life example that we can see? Daily coffee consumption tracked across 10 people reveals consumption patterns through the help of simple counting. So, what does this mean? How many people are drinking 1 cup of coffee? How many people are drinking 2 cup of coffee? How many people are drinking 3 cup of coffee? How many people are drinking 4 cups of coffee? This represents that how many people are drinking 1 cup of coffee. How this represent how many people are drinking 2 cups of coffee. This represents how many people are drinking 3 cups of coffee. This represents how many people drinks 4 cup of coffees. So to make analysis of how much percentage of people are drinking that particular coffee, this you can use by using frequency. So this is one very important example that we discussed here. So this is about the frequency. So what is this relative frequency? Relative frequency turns raw counts into percentages. Like how much this value is present in the data set, how much percentage of value is present in the data set. This particular thing will be explained by the relative frequency. So now to calculate relative frequency we will be using this particular formula. That is let's say this frequency we have, right? This frequency divided by total number of observations, means total 10 are there, so you divided 3 with 10, so you will get the value in some percentage values. So I will take one example to do it. So we took the same data here, that is this data only we took 122 122. Then we are having this third value as 3124 3124, and then you are having these values 3 to 1 3 to 1 3 2 1. So first what you will do, you will create a frequency table. So in the frequency table we will distinguish how many times 1 is present, how many times 2 is present, how many times 3 is present, how many times 4 is present. So here 3 present 3 times, so we will write 3. 2 present 4 times, this 1 2 3 4 times 2 present, so we will write 4 here. Since here 3 is present twice, so we will write 2 here. 4 we will present 1 time, so we will write 1 here. So relative freak, so total is how much? Total you have is 10. Okay, so what you will do, you will just divide this 3 with 10. So 3 by 10, you will get the percentage as 30%. Then you will divide 4 by 10, means 40% you got. 2 by 10 means 20% you got. 1 by 10 means 10% you got. One very important observation is the sum of the relative frequency will always be equal to 100%. Always 100% it will come. So this is if your a value is not coming 100%, let's say 110 is coming, 120 percentage is coming, means somewhere your calculations have been wrong. So it should always come as 100 percentage. So why it matters? It matters because, let's say if a company comes to know that 30% of people are using this particular t-shirt, means company will identify which 30% people are using this particular t-shirt. Then what company will do, company will plan accordingly and they will do marketing campaigns based upon this particular t-shirt data. Like let's say if youth is using this data, this t-shirt, so it will send the message to the youth. So how it is able to identifying using the help of relative frequency. So let's say this mouse is there. So this mouse, let's say 40% of people are using this particular mouse. So what it will do, so from this company will understand, okay, if in my company 40% of people are, or else 40% of consumers are using this mouse, that is from our company. So to find conclusions or to find the decisions based upon this, you use the concept of relative frequency. The third frequency is cumulative frequency. So what is cumulative frequency? Cumulative frequency will tell like how many observations will fall under the each value. Total how many observations are there, that will be told by the cumulative frequency. Like it is very important for data distribution and calculate the percentiles. So to find the cumulative distribution, what you have to do, I will first you have to calculate the frequency. Okay, calculation frequency is very important. So so this particular formula we will be using to calculate the frequency. So what is this fi? So first what you will do, you will calculate the frequency. So first frequency is what? 3. Then what you will do, then this 3, if you add this 3 plus 4, you will get the value as 7. So this 7 will be coming here. Then what you will do, then this 7 that you got, that 7 you will be added with the 2 option 2. Once you add to what you got the value as 9 here. Then what you will do, then you will do 9 plus 1. So that's why what you got 10 here. So what is this, what does this cumulative frequency tell? It tells total number of observations in the final entry. In the final record that you got, that record it will tell you the total number of observations. That is the first thing. The second thing is by using this you can able to tell, let's say we took the coffee example, right? How many people have drank 1 cup of coffee. So what it will do, it will tell the answer is 3 people have drink the 1 coffee. Now the second question it comes is how many people have drank 2 cups of coffee. So obviously 2 cups of coffee means what? The people who have drank 1 cup of coffee also will be counted. Along with that, people who have drinking the 2 coffees also will be counted. Correct. So that's why what will happen. So 1 cup people means how many have drank? 3. 2 cup how many have drank? 4. So total how many people? 7 people. So to identify the total, how many people have achieved this, how many people have achieved that, what is the total percentage? Total percentage of people drinking 1 cup or 2 cup of coffee, that you can identify using the cumulative frequency. So that is why your CF is very important to identify. Let's say one company asks how many, let's say you are creating a Netflix application app. In that, one movie has came, one movie reviews are there. So how many people have given good and excellent review? So obviously the person who has given the excellent review is means that he also like the movie. So good review people also will come, plus excellent people review will also come. So the positive reviews means good and excellent. So if you add both of it, you will get some value. That value, if you divide it with the total, means you will get the answer of cumulative frequency. So this 7 means what? 70% of people are drinking either 1 cup of coffee or 2 cup of coffee. So this is why cumulative frequency is very very important. How many people drank 2 cups or fewer cups? To answer all of these questions, to understand all of these things, we will be using cumulative frequency. So here we took one example to demonstrate all of these things. So to what you have to do, first you have to, let's say this is a data set. Okay, so first you what you have to do, you have to always calculate the frequency. So to calculate the frequency, like here how many times, so what are the values that are there? 4, 5, 6, 7. So here we will first specify the values 4, 5, 6, 7. Then what we'll do, then we will specify how many times, the count of 4 in the data set. So here how many times 2 counts are there? So 4 means 2 here. How many times 5 count is there? 1, 2, 3, 4. 4 count is there, we'll add here. How many times 6 count is there? 1, 2, 3, 4. 4 counts are there. How many times 7 is there? 1, 2. So what you will do, you will take this sum. So total is what? 10 is the sum. Okay, sorry, 12 is the sum. 12 is the sum. Okay, so 6 plus 4 10, 10 plus 4 12 samples are there. So now what you will do, you will find the relative frequency. Relative frequency tells how many people who drank 1 cup, only 1 cup. To find individual, to find only 2 cups, only whenever you get the term as only, use relative frequency. Only 1 cup means what? 16.61 percentage have drank only 1 cup. 33.33 percentage of people drank 2 cups. 33.33% have drank only 3 cups. For this we'll using relative frequency. Cumulative frequencies means what? First we will take the sum, like how many people have drank 2 cups, like 5 cups of coffee. So 4 plus 5 you will take, obviously 4, but if only specified, use relative. When only specified, use relative. But if only is not specified, no need to use relative frequency, use cumulative frequency. So what is the key insights from the data? This data that we done, what is the insights? Scores of 5 and 6 each appeared 4 times, representing the majority of students. 66.67 are combined. So how you got the 66.66? You divided this 8 with the 12 option. Okay, so means what? 2 by 3 you got. So what is this 2.3? If you divide it with this, you will get the value as 0.66. This insight you got because of this cumulative frequency. The what is the second thing? Half of the 6 scored 5 or below, indicating the median falls between the 5 and 6. Means what? Here you see that here half of this thing, like here the what is the total here at 4 5 6 7, right? So in that half of the class, let's say half of the people falls in the range of 5 to 6. So the median that you get will obviously in between 5 to 6. This is the insight that you got from here. The third thing is performance range. Only two students achieved the highest score of 7, while two score with the lowest score of 4. So based upon these frequencies and cumulative frequency, and how much percentage of people got 4, this 16.67 percentage people got 4. So this is how you can able to do this thing, particular thing. So these are the formula. Simple count of occurrence, 5 appears 4 times. Relative frequency means how much percentage of that particular value in the data set. Cumulative means if you combine two particular things, what will be the percentage of thing that comes. So is nothing but the cumulative frequency. So why these concepts matter for data exploration process? This frequency distribution reveal patterns and anomalies in your dataset. So let's say in your dataset, if any outlier is there, if any outlier is there, so what it will do, what this frequency, cumulative frequency do, it will tell where the outlier is present. Okay, if out of the dataset, let's say if we selected this data set like 4455. Okay, but suddenly I will write 50 here. Suddenly I'll write 50 here. So what is happening? You can able to detect the outlier from this frequency table. Second is probability foundation. Since you got all of these things in the form of probability, 16.67 percentage, 2 by 4, 0.3 probability. So these things you can use to identify the probability. Percentile calculation. So 16.67 percentile of people have got 4%. Means the students who got in like these people who got 4 are 16.67% better than the previous students who got less marks. So this is you can identify using the percentile. So visualization preparation, this helps to form the histograms and distribution peaks. How it uses? So now let's say here you got the frequency. So here I'll draw the diagram for frequency. So for frequency, what will happen here? So for frequency, what will happen here? You got the diagram. Like first you got the value as 2. So you will draw one particular thing. Here let's see you are having 2. Then here you are having 4. Then you are having 4. Then again you are having 2. So now if you try to draw the plot between these things, if you try to draw the plot between these things, you will always get like this plot. Means this is not a normal plot. Okay, this type of plot you got. But by using cumulative frequency, what plot you get is, this is for cumulative frequency. Cumulative frequency. Cumulative frequency, what plot you got is, let's say you got first value as 2. Then what you have done, 2 plus 4 you got. So this value you got it as 6. Then you got it the value plus 4, if you do, you will get value as 10. Then you got the value as 12. So what does this mean? The graph, let's say this is 2, this is 4, this is 8, sorry, this is 2 6, sorry, 2 6, this is 10, this is 12. So now if you see the graph, this graph is always in increasing format, always in increasing format. This is the graph of cumulative frequency. If I delete it, here I will write 12 here, and here I will write cumulative frequency graph. So this is the difference between frequency and cumulative frequency. By using the relative frequency, you can draw the pie chart. Like let's say if you are, this is the pie chart, let's say. In that you can divide it into 4 parts, like 16.67, you got this much. Then you can draw like 33 point people got these things. So let's say if this is 33.3, then you got this as 33.3, then you got 16.6. So you can able to draw, again you got 16.6. So like this you can able to draw the pie chart using the relative frequency. So that's why these concepts are very important the for this particular for the frequencies are very important. So now what we will do, we will implement this in coding also. So here what I did, here I will create one file called frequencies dot py. See, in the last lecture when I explained about central tendency, we used the stats module, right? Now here we're going to use the pandas. For it, as implementation in pandas is very easy. So for using in pandas, what you have to do, first you have to install the pandas. So for this, what I'll do, I'll go down here, I'll write pip install pandas. Since mine is already installed, so that's why it is not coming for me. So here I will write import pandas as pd. Then here you will specify the data. What is the data that you specify? Here I'll specify the data as 20 20 30 30 50 50 40 40 40 30. I'll specify. Okay, this is the data that I specified. Now I have to use the frequency. So first step one, what you have to do, you have to convert into series. Very easy. Convert into series. So for converting into series, what you will write? You will write pd dot series. In this, you will write the value as data. Okay, and you will specify this value as in data in df you will going to store this value. Okay, now what you have to do after specific, because for making good presentable format we have to convert it into series. Now what you have to do, you have to use the frequency concept. So how to use the concept of frequency? Here for frequency what you will do, you have to use the concept of value underscore counts. So how to use the value underscore counts? You will write df dot value underscore counts. So what does this df underscore value count do? It will count how many times is 20 is there, how many times is 30 is there, how many times is 50 is there, how many times is 40 is there. It will count this, and we want that it should become our index. It should become our index. So that's why we are specifying this concept of sort index. That's why we are using this sort index. Means what, here we are defining these values and we are sorting it in the increasing order. That's what we are doing. So what does this do? First it will write the all the values. Like first it will take 20. It will write the 20 as how many times is 20 is present. It will write that count. So it will write 1 2 times 20 is present. Sorry, 2 times 20 is present. 30 is present how many times? 3 times 30 is present. 3 times 30 is present. How many times 40 is present? 40 is present for 3 times. And how many times 50 is present? 50 is present for 2 times. So okay, so how if you count this particular thing, you will get the length as 6, sorry, 5, 8, 10 values are there. So 3, 6, 9, 10 values are there. So what you are doing, you are trying to sorting in the ascending order so that cumulative frequency works in very much efficient way. So now what you will do, you will also take the sum also, sum, or else length you can take, anything that works. Now what you will do, if you print the frequency value along with the data, you will get the value as counts also. So if I print the value as print, I write frequency values, frequency, then here I'll specify the value as freq. Now second step, what you have to do, you have used the value of frequency. Now I want to use my relative frequency. So what is this relative frequency? It is nothing but the frequency values divided by the length of the data frame. So what does this length of data? It is the formula to calculate the sum upon total. So the total plays a very important role. So that's why I'll write relative frequency. Relative frequency. For relative frequency, what I will use? I will just write the frequency upon length of, what is the length I want for this data? I want the length. So I will write length of df. So after doing this, what will happen? It will give me the length of this particular data, and this is the function that we use to define the relative frequency. The third one is the cumulative frequency. Cumulative frequency. So this pandas has this by default cumulative frequency function that is present with us. So by default cumulative function that is present with pandas. So to define the cumulative frequency, what you will do, you will write this df that you got. In this df, what you will write? You will write cum sum, cum sum, cumulative sum, you got it. So once you write this cum sum, what it will do, it will print the cumulative sum. So not for df, for frequency we have to use this cum sum, because you will take frequency 2, then you will take 2 plus 3 5, 5 plus 3 8, 8 plus 2 10. For frequency you will going to do, that's why frequency came. So now what we will do, we'll just print these values, print relative frequency, and here we'll write rel fric. Then what you have to do, you have to print the cumulative frequency. Cumulative frequency you will print. Here we will write cum sum, sorry, cum freq. Then I want all of these results to come in one data frame so that it should look in presentable manner. So to make it presentable format, you'll write df. In this, what you will write, you have to convert it into series. So what you have to convert it into series, you will write pd dot series, sorry, pd dot data frame. In this, what I will write, here I will create a dictionary. In the dictionary, what I will write, here I will write, let's say I want frequency. In frequency, what I will write, I will just write freq. Then I will specify my relative frequency. In relative frequency, what I will write here, I will going to specify this. What I can say here, I can specify this relative frequency. Then third comes is cumulative frequency. Cumulative frequency. Then if I want here, this is an yeah, correct, frequency. QUENCY. Then this value will be your cumulative frequency. Cum freq, we displayed it. So now what you will do, you know this index, right? So what we'll do, we'll just print the df. And now if you check this particular output, that is python frequencies dot py, if I execute this, see, you got this value. See, 20 count is 2. So if you divide 2 by 10, 2 by 10, how much? You'll get 0.2 as the relative frequency. 3 means 30% frequency. 4 means this frequency you got. Cumulative 2. 2 plus 3, 5. 5 plus 3, 8. 8 plus 2, 10. So this is how your particular implementation takes place. Imported the data, converted into series, or series is optional. If you want, you can convert, but since we want to use the value account and sort index, that's why we use this particular concept, so that it should come in the ascending order. Then what we did, we used the relative frequency concept, where we use the formula of it and we printed it. Similarly, we also used printed the cumulative frequency and we just displayed in the data frame. So I hope you understood about these concepts. So once the statistics is completed, I will also make lectures on the concepts of Python. So that's it, guys. Please do like, share, and subscribe, guys. In the next lecture, we'll going to discuss about the measures of dispersion. So thank you, guys.